In this video, we will discuss binary search. I assume that you have learned the basics from these resources. We will focus more on the recursive aspect of binary search. Firstly, what's the search problem? The problem is find the position of a target value within a sorted array. If the value is found, return the index. If it's not found, then we have to return -1. One way to solve this problem is to use what is called as linear search. In linear search, we compare our target value with every element in the array until we find the value. But this algorithm is not efficient. For example, if we have 100 values in our array, in the worst case scenario, we need to compare our target value with all the 100 elements in the array. But if the array is sorted, there is a much more efficient algorithm to search for a target value, which is of course binary search. So first we will learn how binary search works with an example. Then we'll see how the recursion pattern that we learnt in the previous video also applies to this problem. Then we will understand the code and finally learn why this algorithm is efficient. Okay, so here's the example that we are going to be solving. We have this array and we want to search for the value 10. So how this works is firstly we compare the value 10 with the middle value in the array. The length of this array is 8, so the middle values are 30 and 40. In this case we'll consider the right hand side value as the middle value. So we'll compare 10 with 40 and we find that the value of 10 is less than 40. So we know that if 10 is to be present, then it should be present to the left hand side of 40 and not to the right hand side. So we have eliminated half the possibilities in the first iteration itself. So what we'll do now is we will take the left half of the array 0, 10, 20, 30 and check whether 10 is present here. So now this is the new subproblem and we have to check whether our value is present in this smaller array. So this is the recursive step. Okay, now once again we will compare 10 with the middle value. In this case the middle value is 20 and once again 10 is less than 20, so we check. Now we create another subproblem. This is the new array 0, 10 and we have to check whether 10 is present in this subarray. Now finally we find that 10 matches with the middle value. I know that this is the last value, but we define the middle index as the array dot length divided by 2. So this is equal to 1 in this case. So we see that the value of 10 matches this middle value and we return the result. So this in this this iteration of the problem will return 1 and we will go back to this subproblem and even this subproblem will return 1 and finally we come back here and we will return 1 again back as the final result. So this is how binary search works. And if we have, let's say we are searching for like 70 instead, then instead of going to the left hand side we'll go to the right hand side. But the logic remains the same. So this is how binary search works. Now let's understand how we were able to apply the recursion pattern for this problem. So you know that for any problem that you're going to solve using recursion, we have these steps. First we need to identify the base case. Next we need to split the problem into smaller subproblems. Then we need to recursively solve each subproblem and then combine the results of the individual subproblems and finally return the result. So we saw all these steps in merge sort. Now let's see the same steps for binary search. So in this case the base case is if the length of the array, okay, let me use JavaScript kind of pseudocode. If the length of the array is 0, we return -1, right? So this is the base case. Now we need to split the problem into subproblems. In this case, let's take this example. The original problem was if the original problem is this array, then the next subproblem is the left hand side portion of the array, because the value that we are searching for 10 is less than the middle value, else the next array could be the other array 50, 60, 70. So in this case you can see that for binary search we only have one subproblem. In merge sort case we saw that there are two subproblems. Here we have only one subproblem. Okay, now the next step is, once you have identified the subproblem, we need to recursively solve each one of the subproblems. So now we need to solve 0, 10, solve the search problem for this value, right, where the array is 0, 10, 20, 30 and the value is 10. And once you have gotten the result, so we get the result as 1 because the index of 10 is 1. We need to combine the results of the individual subproblems. In this case, once again, we don't have to combine the results from multiple subproblems because we had only one subproblem in the first place. So we'll directly return the result of the individual subproblem. So this step is slightly modified, or rather it is like very trivial. This can be also replaced as return the result of the subproblem, right? So this is the third step, and finally we'll just of course we don't have the fourth step in this place, but you can still see that this problem also fits neatly into the pattern that we identified in the previous problem.